AI reasoning has taken a massive leap forward, and the open source community is at the forefront of this revolution. A model trained on just 14% of the data used by its competitors is outperforming industry giants, while another is completely redefining problem solving by adopting an innovative approach to logical reasoning. If you thought cutting-edge AI was only for billion-dollar labs, think again. These new models prove that smarter design can outshine brute force methods. One of the most exciting new models is OpenThinker 32B, developed by OpenThought's team. This model is fine-tuned from Alibaba's Queen 2.53 Tub Instruct. This model is fine-tuned from Alibaba's Qwen 2.53 Tub Instruct and boasts an impressive 32.8 billion parameters along with a 16,000 token context window. But what truly sets it apart is its unique training approach. Unlike many AI models that rely on sheer volume, OpenThinker 32B was trained using a highly curated dataset of 114,000 examples. Each example comes with a detailed metadata, including ground truth solutions, domain-specific guidance, and test cases for coding problems. This careful selections process ensures that the model learns efficiently rather than just memorizing data. To maintain high quality, the team implemented a custom curator framework to verify code solutions, and an AI-based judge was used to confirm the accuracy of mathematical proofs. Training OpenThinker 32B involved 3 epochs, 3 full passes over data using the Llama Factory framework. The training strategy included a learning rate of 1E5, a cuisine learning rate scheduler, which gradually adjusted the model's learning speed to optimize performance. For compute power, the team used AWS SageMaker with 4 nodes, each equipped with 8 H100 GPUs. Despite the complexity of the model, training was completed in just 90 hours. In addition, an unverified dataset of 137,000 samples was tested using Italy's Leonardo supercomputer, consuming 11,520 A100 GPU hours in 30 hours. Even the unverified versions performed decently, but the fully verified model was the clear winner in raw performance. The results speaks for themselves. On the Math 500 benchmark, OpenThinker 32B scored an incredible 90.6%, outperforming some high-profile proprietary models. It also scored 61.6 on the GPQA Diamond benchmark, which measures general problem-solving ability. When it comes to coding, the model hit 68.9 on the LCBV2 benchmark, slightly trailing DeepSeek's 71.2. However, since OpenThinker 32B is open source, it can be further refined by the community, meaning that score could improve significantly over time. One of the biggest advantages of OpenThinker 32B is its open source nature. Unlike OpenAI or Anthropic, which keep their training data and methodologies locked away, OpenThinker is completely transparent. Researchers, developers, and even hobbyists can download, study, and refine the model. This accessibility makes it a true game changer, proving that high-performance AI doesn't have to come from secretive billion-dollar companies. Another advantage is data efficiency. While OpenThinker 32B used only 114,000 training examples, its competitor DeepSeek trained on 800,000. Despite this huge difference in dataset size, OpenThinker 32B still performs at a comparable level or even better in some areas, demonstrating that quality training data is more important than sheer quantity. DeepSeek R1 is another open source model, but one key difference. While the final model is available, its training data is not. This lack of transparency makes it harder for researchers to fully understand and reproduce its results. In terms of performance, OpenThinker 32B edges out DeepSeek R1 in key benchmarks. Math 500 benchmark, OpenThinker 32B scores 90.6%, slightly ahead of DeepSeek's R1's 89.4%. GPQA Diamond benchmark, OpenThinker leads with 6.16% compared to DeepSeek R1's 57.6%. However, DeepSeek has an edge in coding tasks and some math tests, such as AIME benchmarks, where OpenThinker doesn't quite take the top spot. Overall, the competition is extremely close, but OpenThinker's efficiency and open source nature make it a standout success. For those without high-end GPUs, a smaller 7B parameter version of OpenThinker is also available, making experimentation more accessible to a wider audience. Another fascinating AI model shaking up the industry is Yugen 3.5B, developed by an international team from institutions like Ellis Institute, Max Planck Institute, University of Maryland, and Lawrence Livermore National Laboratory. Yugen 3.5B takes a radically different approach to reasoning. Rather than explicitly spelling out every reasoning step, as traditional chain of thought methods do, Yugen 3.B relies on latent reasoning. Instead of generating step-by-step outputs, it refines its internal states until it reaches a confident final answer. This makes it particularly powerful for complex queries that require deep thinking but don't need every step explicitly stated. At the core of Yugen 3.B is a concept called recurrent depth. During interference, the model loops through its internal state multiple times, refining its understanding with each pass. This is similar to how human might solve tough math problem, going over their work multiple times before arriving at the final answer. This looping mechanism has two major benefits. Number one, it improves reasoning quality by allowing the model to refine its thoughts without requiring a larger context window. Number two, it enhances memory efficiency by avoiding the need to generate excessive immediate reasoning tokens, which can quickly consume computational resources. Yugen 3.5B is still a transformer-based model, but with a loop processing unit that allows additional rounds of computation at interference time rather than increasing the number of static parameters. This means the model can adjust its complexity dynamically, using more loops for difficult problems and fewer for simple ones, optimizing both performance and efficiency. Yugen 3.5B was trained on massive 800 billion tokens spanning general text, code, and mathematical reasoning. This diverse dataset ensures it can handle a wide range of reasoning. When benchmarked, Yugen 3.5B outperformed larger models like Pythia 6.9B and Pythia 12B, proving that smart architecture design can outweigh brute force scaling. It excelled on reasoning-heavy datasets like ARC, a standard test dataset for AI models, and GSM8K, a benchmark for math reasoning. One of Yugen 3.B's biggest strengths is its ability to adapt interference cycles based on task difficulty. If a problem is complex, it runs extra loops to refine its solution. If the problem is simple, it uses fewer loops, saving computational power and speeding up results. This adaptability makes it highly practical for real-world applications where efficiency is crucial. Both OpenThinker 32B and Yugen 3.5B are pushing AI reasoning in new directions, one through data efficiency and open source accessibility, the other by revolutionizing internal reasoning with recurrent depth. These models demonstrate that AI progress isn't just about throwing more data in compute at a problem, it's about smarter design, better training strategies, and challenging the status quo. As AI research continues, these breakthroughs suggest that open source models can compete with and even surpass proprietary ones. And the future of AI isn't just about who has the most resources, it's about who thinks smarter.